Here is an explanation for the answer to final exam question number 84 in Alternative Energy Demystified, 2nd edition. If you have the printed book, you'll find it on page 329. We're talking about a liquid-fueled rocket engine, a conventional liquid-fueled rocket engine. None of this fancy stuff like ion propulsion or nuclear propulsion or solar sails or the Bussard ramjet or any of these other things. Just a plain old rocket engine like the one that they launched the space shuttles with. A liquid-fueled rocket engine for transportation in outer space. Which of the following substances never serves as part of the propellant, either the combustible fuel or its oxidizer? Well, the answer to this question is C, liquefied carbon dioxide. That will neither burn nor help anything else burn. In fact, carbon dioxide is pretty well known as a gas that will interfere with combustion. It also interferes with respiration, and it has other effects which in alternative energy are of some interest. Carbon dioxide produced by human activity may contribute to climate change and all of that. But in a liquid-fueled rocket engine, we can use kerosene, hydrazine, liquefied oxygen, or nitrogen tetroxide as part of either the propellant or its oxidizer. So we can look back in chapter 6 and we find figure 6-4, I believe it is. I've modified that a little bit geometrically so it'll fit on the screen better, and so that the thrust is indicated. The thrust, this engine is propelling from right to left. From right to left, just like that. That is the direction in which the space vessel will travel. The exhaust, of course, going out towards the right, pushes this thing along through space. The propellant comes in one side of the engine, the oxidizer in the other, and they combine and they burn and they produce this hot gas which comes out as exhaust. One of the interesting things about a rocket engine in the vacuum of space is that this exhaust doesn't have to come out of there very fast. As long as it keeps coming out continuously, this vessel will continue to have thrust in this direction from right to left in this case, and will continue to accelerate indefinitely. So even if the exhaust were coming out at, say, 1 kilometer per second, that doesn't mean that the spaceship would have a maximum possible speed of only 1 kilometer per second. It could continue to accelerate indefinitely as long as that exhaust kept coming out of there. That is in contrast to a jet engine in the atmosphere, where if, for example, the exhaust comes out at 550 miles an hour, what's that, a little over 800 kilometers per hour, that dictates the maximum speed that the aircraft can attain in the atmosphere. In outer space, things work differently. But in any case, we will never find either this propellant or its oxidizer, neither the actual fuel, the propellant, sort of like the gasoline in your car, and the oxidizer, sort of like the air that comes in to the carburetor. Neither of those substances will ever be carbon dioxide. So once again, the correct choice for this question is C.